All right, when we're working through some of these math problems, general guidelines. You always want to list the known values from the problem using appropriate variables. And then you also want to make sure that you list what you are trying to find. Now, keep in mind, listing the known values, those are also the ones that are implied. So if an object is in free fall, we have to know that we have acceleration due to gravity. If an object is being dropped, we have to know that its initial velocity is 0. Okay, the second thing, sketch a picture if applicable. Usually I will use a picture for an object being thrown up and then falling back down. And then the third thing we want to do is we want to try to find a formula from our list that relates all of the variables together. So the variables that we wrote up in here, we're going to try to find a formula that relates them. We're going to look at 4 different problems. Now, I'm not actually going to solve the problems in this video. That will be in part 2. But what I'm going to do is I'm going to get all of the values listed, sketch a picture if needed, and then give you the opportunity to solve it. Okay, so if you want to check your answers, make sure you watch part 2 of these videos. Okay, so problem number 1. It says that an object is thrown into the air with initial speed of 25 meters per second. What is the total time that it is in the air? Okay, so an object is thrown into the air. I'm going to assume that it's thrown upward, and it has an initial speed of 25 meters per second. Okay, so speed is the magnitude component of velocity. So our initial velocity, we're going to list the items we know, is 25 meters per second. Okay. It's asking us for the total time in the air, so we don't know what our time is, so T is a question mark. And then there's one other thing that is implied. Because the object is technically in free fall, we know that our acceleration is due to gravity. And we're just going to go ahead and use the 10 meters per second per second. Now, on problems where you have an object that's being thrown up and being thrown down, we actually need to make sure that we put the negative sign in with our gravity symbol, because this initial velocity is upward and our gravity is pulling the object downward. So we need to use the positives and negatives to indicate the direction. Okay? Typically in physics, upward is positive and downward is negative is kind of the standard generalized rule. Now, if we only have an object moving downward only or moving upward only, then it's not as important to make sure that we have the positive and negatives. We just have to be consistent in that. All right, so because this is an object that's being thrown, we probably want to separate our motion in half. And so I know that the time going up is equal to the time going down. And then the other thing I know is that right here at the top, my velocity is equal to 0. So on my list over here, I know one more velocity. Well, if my initial velocity is 25 meters per second, I am going to look at the upward motion as the part of the problem I'm going to solve. So because that's my initial velocity at the top of this motion, I'm going to call that my final velocity is equal to 0. So now what I want you to do is I want you to go and look back at the formulas and see if you can decide which formula you could use to solve this problem, and then go ahead and try to solve it. Okay, we're going to move on to problem number 2 and get that one set up. All right, so problem number 2. An object initially at rest accelerates at 3 meters per second per second. How far will the object have traveled in 10 seconds? All right, so if we list our known information, it is initially at rest. So that means my initial velocity is 0. Okay. Accelerates at 3 meters per second per second. So 3 meters per second squared. How far will the object have traveled? So it's asking me for a distance. And we know that our time is going to be 12 seconds. Okay, now this one, it doesn't indicate that we have an object being thrown or anything, so we don't have to worry about the picture of the upward motion and the downward motion. So now what we want to do for this one is you want to go and look at your list of formulas and try to decide which formula relates these items to each other, and then see if you can get the number substituted in the formula and solved. Okay, problem number 3. If you throw a rock upward, with what initial velocity must it be thrown with to stay in the air for 20 seconds? Okay, so we are going to throw a rock upward. What initial velocity? So we are looking for the initial velocity to stay in the air for 20 seconds. So we know our total time is 20 seconds. And because it's an object that's being thrown, we know that our acceleration is gravity, which is, we're going to use just our 10 meters per second squared. And again, this one, we want to make sure we use our negative 10 because we are throwing an object up and it's coming back down. Okay, now I'm going to split my picture in half. That was kind of bad. And I know that my time upward is equal to my time downward. So I know that for the first half of the motion, I have 10 seconds. And for the second half of my motion, I have 10 seconds. So we want to make sure we kind of keep that in mind, that this 20 seconds is the entire motion. And let's see what else. We know the velocity at the very top here is equal to 0. So I'm going to go ahead and use the first part of the motion again. So my velocity at the peak there would be my velocity final. Okay, make sure you're careful on this one because I'm not going to use the 20 seconds when I use my formula. I'm going to use 10 seconds because I'm only looking at half of the motion. So now go back to those formulas, see if you can figure out which formula you could use and see if you can get that one solved. Okay, and the fourth problem, the last problem. An object is dropped off of a cliff. How long does it take to travel 180 meters? All right, so the object is being dropped. That means our initial velocity is equal to 0. How long does it take? So we're looking for time. We know our distance is equal to 180 meters. And because the object would be in free fall, we also know that our acceleration is due to gravity, which is going to be 10 meters per second. Now on this one, because we don't have motion going upward and motion going downward, we don't necessarily have to put the negatives on there. This is where it gets a little bit tricky. If I choose to do the negative 10 meters per second because it's going down, we also actually have to put a negative on the distance, because if this is my cliff, when I drop the rock, the distance it's covering is downward, so we would have to put a negative there. Now, if we don't want to do that, we can take the negative off of both of them. Nope, leave the 10 though. Okay, so either way will work. You just have to make sure that you are consistent. All right, now that you have all the variables listed out, again, see if you can figure out which formula you could use in order to solve this one. Now, to check your answers to these 4 problems, go ahead and watch part 2 of this because I'm going to go back and I'm going to solve each one of them out.